Hello everyone, this is Shatarupa and welcome to Rasayanika. So hope you all are doing well. So today this is our second day for the live session of CSIR NET June 2021 question paper discussion. Okay, so before starting, I want to know from you all that am I audible? If I am audible, just type yes or anything in the comment box so that it can be visible to me and I can continue. If I am audible, please type yes or anything like that in the comment section so that it can be visible to me and I will continue. Okay, so before starting, I want to say that I want to ask actually from everyone of you that how was your examination of CSIR NET? This time in the February month, in the 16th, right? 16th February it was happened. And how was your examination? So please type if I am audible and also if it is good or not or anything related to that, please type in the comment box. Okay. I think 2 or 3% have joined yet. So just I want to wait for 1 or 2 minutes. After that, we will start. Just wait. Just I'm waiting for 1 and 2 if there. Then it will be good for you, right? To discuss these questions. Okay. I think there are no one till now. Okay, so let's begin. Let's begin with today's session. So this is our second day of discussion for the CSIR NET June 2021. That is a question paper discussion and the second day. Okay, so yesterday, another faculty member of this Rasayanika have already discussed the few questions and related to mainly they were right for the organic equations, right? So today I am going to discuss some physical chemistry questions and also some inorganic equations for this CSIR NET June 2021 from this actually. So let's start. Yeah. So this is our first question in a screen. So this was the among the following which set of molecule or ionic species all have a planar structure. So actually they have been asked the questions like that you have been asked actually in the examination. The among these molecules, these inorganic molecules which showing the actually the planar structure. This is a very pretty simple question and it is from your chemical bonding VSEP pair theory. Okay, VSEP pair theory. So you all are knowing this, I know. So if anyone among you would like to answer the question, can you please type the answer in the comment box? Okay, so I think no one wants to answer this. So it was a very pretty simple question. Okay, so let me answer this first. The correct option will be actually this one. This is option C. Okay, the correct option will be option C. This. So here you can see that ClF4 minus, BrF3 and XCF5. That is ClF4 minus. Okay, let me choose the red ink. ClF4 minus, BrF3 and the XCF5. These three molecules actually show the planar structure, and no other molecule is showing the planar structure. It's a pretty simple question. Okay, so how to solve this? How to solve or how to approach? What will be the approach to solve this type of question? It's very easy question. Okay, so let's start with the VSEPR theory prediction and the structure prediction things. Okay, so if we start with the ClF4 minus actually, ClF4 minus, yeah, ClF4 minus, right? So here we can say the halogen has the peripheral in this valence shell, it has 7 electrons, and also there is a -1 charge. Okay, so that is total 8 electrons, 8 valence electrons. It shows. So 4 fluorine atoms has been bonded with this. So we know this, the number of bond pair, we need to find actually the number of bond pair and the number of lone pair here. Okay, and after that it will be pretty simple for you to predict the structure. So here the number of bond pair will be 4 because 4 fluorine atoms are attached to this. And how many electrons are remaining there? So totally we had the 8 electrons, and now 4 electrons are participating in the bond formation, and we will have only 4 electrons left. So by 2 we will get 2. That is, what is 2? That is 2 lone pair. So now we have number of bond pair is 4 and number of lone pair, that is 2. So 4 bond pair, 2 lone pair system. It is pretty simple. It's square planar structure. Okay, so it is square planar structure. So it is a planar structure. Okay, so next move to the another molecule, that is BRF3, right? So BRF3. How we? In a similar way, we can predict this. Bromine also has a 7. That is a 7 valence electron, that is a halogen molecule, right? So 7 valence electrons. In this, the bond pair, number of bond pair is 3 because 3 fluorine are attached to this. So 3 electrons actually participated to bond formation. Okay, so they had total has 7 and 3 are used, and now the number of lone pair, what? That is 7 minus 3 by 2. That is what? That is 2. Okay. So 3 bond pair, 2 lone pair, and what is this? Is a trigonal perimeter, a trigonal planar structure. Okay, so we all know this, trigonal planar. And in the similar way, we can also predict the structure of XCF5, and we can see that is a pentagonal planar structure. So it's a pretty simple question. These 3 molecules show the planar structure. Okay, so anyone is there? Okay, I have got some comment, that is Swiro, PA1 Swiro. Actually, I can't actually pronounce your name. So, hi, whoever you have commented, and good evening. Yeah, it's a very good evening to you all. And if you got this answer, if you understood my answer explanation, please type yes. And then I would like to move to our next question. Okay. Okay, so let's move to our next question. Yeah, could please send the link of CSIR 2021 question paper PDF. I think question paper, if you have been given the question, the examination, if you have already the PDF, I can see. Actually, I know that. And if you have not given the examination, then you can go to the CSIR official website and you can get from there. And also stay with us till the end. We will send something link in the comment box. You can use those also. Okay, so let's move to our next question. And our second question is, it is another question of inorganic question actually. The question was the effective magnetic moment in Bohr magneton for a lanthanide, that is F10 ion, is approximately what? That is, you have been asked here the lanthanide F10 configuration, that is F orbital, and the electronic configuration is F10. Yeah. So you have been asked basically the effective magnetic moment. Okay. So it's pretty simple question. Would you like to answer this question? It's a very, very easy question. This time actually inorganic part was very, very easy. I think you will also agree with me. So it was a pretty simple question. So would you like to answer this question? What is the correct answer among these all options? Option 1, 2, 3 or 4? Option 1 is 10.6, 2 is 9.92, 3 is 9.59 and the 4 is 7.94. If you would like to answer this question, please type in the comment box, okay? Okay, so let's start to answer this question and to solve how to solve this question. Okay, so the correct option will be the option 1 here. Yeah, this one. Option 1, that is 10.6. Now how to find this magnetic moment? It's a pretty simple question. For lanthanide, you all know that we know the formula. It is for magnetic moment. It is what? That is G into root over J into J plus 1. Okay. This is our formula. This is in Bohr magneton. Actually, the unit is Bohr magneton, BM. So now you have to find first the J value and also the G value. Now how to find? So let's start with our configuration. That is F10, right? So you all know this, F as a 7 orbital system. So 1, 2, 3, 4, 5, 6. Yeah, it's 7. Yeah. Now we have to put this 10 electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So here the arrangement. And now you can see there are 4 unpaired electrons. That is N unpaired electron. Number of unpaired electrons is 4. And now you have to find what? Firstly, the J value. Now how the J value is? J equals to L plus S. Okay. So you have to find first the S. What is S? S is N by 2. You all know this. So 4 by 2, that means 2. So S is 2. Now you have to find what? The L value. It's pretty simple. You all know the azimuthal quantum number for this. That is 0. This is minus 1, minus 2, minus 3 and it is plus 1, plus 2, plus 3. Now how to find this? Just multiply these things with the number of electrons and with the azimuthal quantum number. That is 3 into 2 plus 2 into 2 plus 1 into 2 plus 0 into minus 1. This minus 0 into 1, sorry, 0 into 1 plus minus 1 into 1 plus minus 2 into 1 and minus 3 into 1. So if we add these things, we will get the L value actually. L equals to, it becomes 6. Okay. So L becomes 6 here. So let me erase first for this. Yeah. Yeah. So now we have our S value. Our S value becomes 2 and the L value is 6. So what will the J value? L plus S, that is 8. Yeah. So now how to find the G? The formula is for the G actually. Yeah. For the G value, For the G value, G equals to what? Now 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2 into J plus 1. This is the formula for G. Okay. So now put the value here and you will get the G approximately 1.25. Around 1.25. If I remember this, it will become 1.25. We can calculate this. This time the CSIR also has provided the calculator, electronic calculator there in your, that is digital calculator. So you can put the value there and you can count this. So that it will come the 1.25. And now what is the mu value? That is G into root over J into J plus 1. So if we put the value here 1.25 into root over J means 8 into 8 plus 1 means 9. Okay. So it will become around 10.6. Okay. This is our correct option. This is a pretty simple question. So you have to remember this the basic, actually the formulas, how to predict this, and if you know this, it will be very, very easy for you to predict the answer, and it will be a good thing. So I hope it is clear for you all. Okay, Pallavi answered option C. Yeah, Pallavi, this is not option C. The option 1 will be the correct option, that is 10.6. Okay, so hope you have you understood my question. Okay, so not there in the website, madam, CSI 2021 question paper. Just wait for a few days. I don't know your name actually. So whoever you are, just wait few days. Within some days, CSIR will upload the official question paper in the website. Or otherwise, just stay with us till the end. We will also provide in the comment box some links, so you can go through this, and also you can take the help from those. Okay, so let's move to our next question. Okay, so next question is, yeah, this question. Okay, so this is another inorganic question. And so the question was, considering following statements in the context of NO and CO ligands. So the options were, actually you have to say which options are the correct statements, or the correct options actually, correct statements actually. So the statements are, A, in the bent mode, NO donates 3 electrons to the metal center. And B, statement B is, in IS spectrum, the nu of NO for the bent nitrosyl ligand typically lies between 1525 and 1690 centimeter inverse. And option C, the HOMO of NO and CO are pi star and sigma orbitals respectively. Okay, so these are the basic statements they have given. So you have to say which were, or some one or two more than options actually, the statements are correct or not. So would you like to answer this question? Okay, so Pallavi said yes, ma'am. And thank you, madam. Whoever is PA1 SWAERO, I don't know who is using this. Okay, so you said thank you. Okay, welcome. Papri also answered option B. Okay, Papri, you have answered the option B will be the correct option. Okay, so Pallavi also answered option B. Okay, so let's see which will be the correct answer. So let's see how to solve this question. So the correct option will be actually the option 2, this one. Yeah, 1 minute. Yeah, that is both option B and C will be correct statement here. Option B and C are the correct statement. So why this? So let's see with the option A, that is statement 1. In the bent mode, NO donates 3 electrons to the metal center. This is absolutely wrong. You all know this. In bent mode, NO donates actually 1 electron. You all know this. And in the linear mode, it donates actually the 3 electrons. Okay, so it's completely wrong. So it is not right. So A will eventually, you can cancel this. And now the option B. In IS spectrum, the nu of NO for the bent nitrosyl ligand typically lies between 1525 to 1690 centimeter inverse. Yes, this is absolutely right. Actually, if you see the stretching frequency, so for neutral nitrosyl, it becomes like around like 1700 something. And when it becomes to like, it becomes for the bent nitrosyl, that is NO minus, so it decreases. And when it becomes for the NO plus, that is the linear nitrosyl, it increases. So basically the stretching frequency for NO minus, stretching frequency for NO, neutral NO, and stretching frequency for NO plus. So what will be the order? So if we see the highest order for the NO plus, this is linear, and then the free nitrosyl, and least the NO minus, that is bent nitrosyl. So it has the lowest value among this also. So we can see below the 1700, around 15 to 25 to 16 to 90 centimeter inverse. So this is also correct question, correct answer option. And let's move to this statement 3. C actually. The HOMO of NO and CO are pi star and sigma orbital. So for this, we need to know basically the MO diagram for NO and CO. And this is pretty simple. You all know this from your from your graduation level, I know this. So if we see this for the carbon monoxide, this is for the CO molecule. So we see the HOMO here. What is the HOMO actually? For the CO molecule, actually we can see the HOMO is absolutely, this is the sigma orbital, because this one, yeah, this sigma. Yeah, this sigma one. And if we see for the NO, the HOMO will this pi 1. Okay. So that put the electrons basically. So here for carbon, you all know that 1s2, 2s2, 2p, 2p2 actually. So for the 4 electrons, you have to put here. 1s is already not given. So the 4 electrons means 1, 2, 3, 4. And here also 1, 2, 3, 4. So basically 4 means 4. This 8 electrons. So 1, 2, 3, 4, 5, 6, 7. And 8. So it is basically the HOMO. This is sigma orbital, basically nothing there, nothing that. So you can see this is the basically thing, and thus we can see these 2 options are the correct option, and here the B and CBC option are the correct option. Okay, so if I am clear, I want to move to the next question. Okay, so if anybody answered anything in the, am I clear to everyone? If yes, you can type there, okay? Okay, so let's move to our next question. Yeah. Question number 4. This is another inorganic question, and the question was for mercury Ag2 the bond order and the orbitals involved in bonding are respectively what actually? So basically they have asked you, that is the Ag2 to form this mercury 2 ion, and what will be the bond order and which orbitals mainly involved to form this bond actually. So many of you, I know that you will think you have to answer in respect of the MO diagram, right? So basically you should know the MO diagram of the mercury or like that. So I want to say this is a very confusing term, this MO diagram here, to solve this, but it's pretty simple. It's a straightforward question actually. If you really want to solve this question, just apply a few basic concepts, just apply these things, or a basic knowledge, you can easily find the solution for this question actually. So you want to anyone who would like to answer this question? Okay, so Papri answered yes ma'am. Oh, I think it's for the previous question. Okay, so anyone would like to answer this question number 4? Which will be the correct option? The options are 1, S or S orbital. Option 2 is 2, S and P. Option 3 is 1, that is P and P. And option 4 is 3, that is S and S. Pallavi answered the option C. Okay, so Pallavi answered the option C. So let's see whether it is correct or not. Okay, so how to solve this? So let me tell you one thing. You don't need to know basically the MO diagram for the mercury or anything like that. You don't need to know. This is not, you will think that this is not your syllabus, not within your syllabus. You don't need to understand in respect to your MO diagram. Just apply your simple concepts. So what to do this? So basically you all know this for the mercury. Okay, let me change the ink first. Yeah. For mercury, what is the basic actually the electronic configuration? You all know this. It's for the valence shell electron. We can see that is 5d10 and 6s2. Okay. So when we want to actually create the Ag+, that's the cation, right? Ag+. So what is going to happen? So one electron will remove from the s orbital. This is the most periphery or more the valence electron, so it will go from this. So now the electronic configuration becomes 5d10, 6s1. Now how it is formed? Ag2. Ag2, 2 plus means how it is formed. This is pretty simple, nothing but the combination of both the mercury plus ion, that is Ag plus and Ag plus. These 2 electrons will overlap with each other and they can bond. They can easily give this Ag2 2 plus ion. So now which orbital is participating in this formation of this bond? That is the s orbital and this one electron. Okay, so basically the s orbital. So and the bond order which will be found like 2 electrons are participate, right? So bond order will be 2. So yeah, this is nothing but the correct option will be option 1. This one. This is 1. This 2 electron means 1 bond. one bond is forming, 2 electrons are participating, that is 1, bond order is 1, and the s orbital actually they participated here. Okay, so basically this one. Okay, so that is 2 electrons mean, that is the one bond, that is bond order is 1, it's 1, and the orbital are s orbital, basically this. It's a pretty simple question. You don't need to think in the respect of the MO diagram or something like complex situation, anything like that. You don't need to think like that. Just basic things, some how to form this molecule, you can easily answer this type of questions. So I really want to say that this time inorganic questions were pretty simple, mainly straightforward questions. So if you have given this examination, it will be very easy for you in respect of this inorganic chemistry actually. Okay, so I think I am clear to everyone. If yes, I want to move to the next question. Okay, so here, this is our 5th question. This is another question from your inorganic and basically from your group chemistry. Okay, so the question was, identify the correct statement for the 2 reactions given below. Yeah, the reactions are given below here, that is xenon and the plutonium hexafluoride also reacted with the in presence of SF6. Okay, so these are the basically the complex are formed, and the second reaction is also HCF4 with the Me4NF, and the complex is like that. So you have to say which statement or statements are the correct one. So what is this? Is related to acid-base concepts, right? So which will be the correct option? Anyone would like to answer this question? If you know this answer, you want to answer this question, you can easily type here in the comment box so that I can see your comment and I can say that whether it will be correct or not. Okay, so let's solve this question. Pallavi also answered the option D is the correct option. Okay, so let's see which will be the correct option. Okay, which is the correct option. Okay, so the correct answer will be the option 4. Pallavi, it's not C, it will be option D. Okay, yeah, this one. That is, here says that xenon acts as a base and HCF4 acts as acid. So if you see in this mechanisms, reactions is this, just see the reactions. In the first reaction, xenon and PTF6, if they react, then we will get that Xc plus and a PTF6 minus. So it is easy for you to understand this. Xenon actually provides the electron, that is donates the electron to PTF6. So basically the element which donates electrons, so that is basically the base. Okay, the Lewis base concept actually. The particle which or the element which provides or gives the electrons to another one, that is called basically the base, and the particle or the element which accepts the electrons from another one, that is basically nothing but acid. Okay, so this is a pretty basic simple concept which you need to know. That's the Lewis acid base concept. Okay, so here xenon actually donates the electron, so it acts as base. And the second mechanism, if you see this, yeah, so basically it's a fluoride HCF4. If we see that it is another complex which is an fluoride ion acceptor, that is, it accepts electron. HCF4 accepts electron, and that's why it formed the HCF5 minus, the fluoride ion acceptor. This is basically Me4NF is a fluoride ion donor, and it accepts HCF4, eventually accepts the electrons. So basically it's a Lewis acids concept. So in the first statement, xenon acts as base, and in the second statement, that is HCF4 is the mechanism actually, the HCF4 acts as the acid. So the option D will be the correct option. It's a pretty simple question, right? So I think you understood this question answer, right? The explanation also regarding this is the same thing. Okay, so if it is clear to everyone, okay, so just if you want to type here yes, or you understood everything or not. Okay, so let's move to our next question. Yeah, so before moving to our next question, I would like to say that we are introducing a CSIR NET coaching actually for the chemical science from the Rasayanika, respects on behalf of us actually, and it is started. Actually, it has been started today in the morning batch. Actually, it is already started. From the 4th March today, it has started, and you can also this class join class for the chemical science preparation for you regarding your CSIR NET. And the goal-oriented teaching methods employed in every class. What we provide actually, read classes by CSIR NET experts, and printed hard copy will be provided to you, including the study materials, and class test for every month and for every week also we will take. And unlimited experts assistance and doubt solving via chat. So if you have any queries regarding this, just call in the toll-free number or visit our website given below there. The link is also given below there. Just call and ask there, and you can easily join this this session for your upcoming CSIR NET examinations. Okay, so let's move to our next question. This is the 6th question. Okay, the question was, it is basically nothing from, I can say that from your nuclear chemistry actually. So the question was pretty simple. This question was the penetrating power R and the ionizing power I of alpha, beta and gamma rays following the order. You have to answer the order actually. What will be the correct order regarding the penetrating effect and the ionization effect? Okay, so for the alpha, beta and gamma particle. So it's a pretty simple question. So there are so many options, and within those, do you want to answer this question? If yes, which will the correct option? You can type in the comment box. Okay, so let's see which is the correct option. So it was a pretty simple question from this CSIR NET examination, this 16 February, which was happened actually. So this was from your nuclear chemistry. And to answer this type of question, you don't need to remember or mug up anything like that. You don't need to remember such information in your head, like mugging up those things. Just apply the few important concepts related to this. So any particle which is very, very lighter actually. So light element. So the particles which are very, very lighter, so higher will be the penetrating effect. It will be very easy for them to penetrate. So as well as we see the lighter element, the weight is very light for them, so they will easily penetrate. It will be very, very easy for them. So among the alpha, beta and gamma ray, we can see that the gamma ray is the most lightest. That is the lightest element, right? So it has no charge, and also it's a ray only, so no mass actually also. So what is this? Is the lightest element actually. So it will show the highest penetrating power, and after that the beta particle and the heaviest particle among this all those we knew, that is the alpha particle. So the penetrating power actually, the order will be here. Penetrating power means R, that is R of gamma will be higher than R of beta and then R of alpha. Okay. So also we know this, for the ionization power, ionizing power is just inverse of this penetrating power, just inverse of this penetrating power. That is, R is direct or inversely proportional to the ionization power. Okay, or ionizing power, whatever you want to say. So the order will be just reverse of that. So ionization power basically for the heavier element, or which has large amount of charge, that will be easy to ionize, okay, to get ionized. So ionization power for alpha will be higher, then it will be beta, then it will be for gamma. So the correct option will be option 4. Yeah, this one. Option 4 will be the correct option. So it's a pretty simple concept. If you know this, you really can answer this, that the lighter element will show the most penetrating power. That's it will be easy for them to penetrate, and the heavier element or which has the most largest amount of charge, it will easily get ionized. Okay, so this is the basic concepts actually. So I think you got this. If you got my point, say yes in the comment box easily so that I can move to the next question. Okay, Pallavi also answered maybe for the previous question maybe. Okay. Okay, so if I am clear to everyone, I would like to move to our next question. Yeah. So our next question is also regarding from your coordination chemistry actually basically. So the question was for the ligand to metal charge transfer, that is LMCT transition in the oxoanions given below, the wavelength of the transitions are in the order. So they have given here the wavelength of transitions. Okay, the wavelength of transitions in the given order actually. So what it would be? What would be the correct option? Would you like to answer? Okay, so let's just jump to our solution. What will be the correct option? So the correct option will be the option 1. Yes, this one. Now why this option? So if we see the molecules like the which have been given here, the all the oxo compounds actually is for the vanadium, chromium and manganese, and also molybdenum, tungsten and chromium also given here. They are giving a series. So one by one, if we see like VO4, it's VO4 3 minus, right? Okay, VO4 3 minus, right? So what will be the oxidation state of vanadium? So oxygen we all know that's -2, that is 4 into 2, that is -8, and +3, that will give the V is +5, right? And then for the next one will be chromium, CrO4 minus, 2 minus, right? So it will again give the chromium to +6 if we find the oxidation state for chromium, and similarly for MnO4 minus, right? If I am not wrong, these are the molecule. It will give the +7 oxidation state. So as we see, with the increasing of the oxidation state, the charge oxidation state, that is the +5, +6, +n. With increasing the oxidation state, what is going to happen? The energy difference between that is the metal to ligand charge transfer, right? The ligand and the metal, the transferring between this, the energy difference, it will, what is happened, what going to say, what it is decreased actually. So if we see like the orbitals or the energy diagram for this, so suppose this is for manganese, the iron actually, this is for chromium and this is for vanadium, right? And here is the oxide, O2 minus, oxo anion, right? So all ligands is also for the oxide actually. So we see with the increasing of the oxidation state, the energy difference, it will decrease, okay? It will decrease. So as we know, the energy difference, the E is the energy actually, is inversely proportional to the wavelength, okay? That is lambda, inversely proportional. So it is decreased with the increasing of oxidation state. So wavelength will be just the reverse of that. The wavelength will be higher for the maximum for this manganese, and chromium, and minimum for the vanadium, okay? So, and again, if we see for the same group elements like molybdenum, the chromium, molybdenum, tungsten, this type of group elements. So along the group, down the group actually, if we see, the size will increase, okay? Down the group, the new shell, actually the electron shell is added. So the size increase, we all know that. So with increasing size, we also know that the energy difference here, it increases. So wavelength become decreases, okay? So this is the thing, basically the correct option. Yeah, the correct option will be option 1. Yeah, this one. Yeah, this is the correct option. Sorry, some technical mistakes maybe from my sides. Okay, now it is visible to everyone, I think. So option 1 is the correct option. Here we can see this series will be the correct option. It's a pretty simple, actually, the conceptual question. If you have this general idea about this oxidation state or basic things like coordination, related to coordination chemistry, right? So you can easily answer this question. And if I'm not wrong, this type of questions previously in the previous year also they have asked in the NET and also in the GATE. You can find this type of similar type of questions also there. Okay. So if I am clear to everyone, I would like to move to our next question. Yeah. This is question number 8. Yeah. Our next question is it's actually matchmaking question. So match the items of column 1 with the applications given in column 2. So basically the column 1, some things will be given there, and you have to match with the applications of those in the column 2 is given. So you have to match. So what will be the correct option for this question? Anyone would like to answer this? So, okay, so how to solve this question? This is pretty simple and it's actually memory-based question. So, if you say this question, only if you know any one of this among this also, you have any just general idea, the basic idea of any one of those in the left-hand side. This column, in the column 1, if you have any one, you know any one of those, you can easily answer this because the options are like that. Here, if you can answer only one thing, easily all the answers will be correlated with that, and you can easily answer. So we all know this, the basic things you should know this. That's the lithium mainly used in battery. So basically, C will goes with the battery. So here, where C with the matches with the option 4, right? This is option C. Yeah. Another you can see the platinum alloy is for the fuel cell. It is used in the fuel cell also. So D, it's, yeah, option 3. And anything B is 1, C is 4. So B is 1 means, yeah, that is solar cell. In solar cell, actually, indium tin oxide is used. And zeolite is basically carbon dioxide capture. Its application. When zeolite is used in the application of the carbon dioxide capture. Okay. So basically option C will be the correct option. Yeah, this is the correct option. So it's a pretty simple. If the options are like that, it's a simple way. If you know any one among those things in the column 1, you can easily correlate with the other ones and other one, and it will be easily give you the result. Okay, the correct option actually. So it was a pretty simple question. So let's move to our next question. Yeah. Yeah, this is another question, and this is from physical chemistry actually. In this time, physical chemistry questions were somewhat actually, I can say not difficult, but there were something calculations were somewhat some lengthy calculations in some questions. And in some question, if you know the basic concept regarding the calculations regarding those things, you can easily answer those questions. Otherwise, you couldn't answer those. So physical, I will say, it was moderate. It was not too difficult, but yeah, so many questions where the calculations were tough, and the calculations of so many were very much actually lengthy for the calculation. So we will all solve those things one by one. So today I bring here for you this question actually from physical chemistry, and the question is the volume of nitrogen gas absorbed at STP to form a monolayer. This is basically from your adsorption question actually, from your surface chemistry. So monolayer adsorption, and it is given on a porous solid surface, and the volume is given, that is 22.4 centimeter cube gram inverse. So if the area occupied by one nitrogen gas molecule is 16.2 angstrom square, that is one nitrogen molecule area is given to you. So then the surface area of the solid is close to what? So basically, they asked the surface area, the solid, total surface area for the solid. So how to approach this question? This is a very conceptual question, and if you know the basic things of the surface chemistry, you can easily answer this question. So would you like to answer this question? Anyone from you? Okay, so let's answer this question. Okay, so how to solve this question. So the correct option will be basically the option 2. Yeah, this will be the correct option. Now, how to approach this solution? Okay, so basically, here actually you have been given the volume of nitrogen. Okay, so volume of nitrogen is given here. Yeah, this one. And this is given in the STP, that is standard temperature pressure in the time. It is already given in this time. The monolayer adsorption is in the STP state. And you have been also given the one molecule of nitrogen, the area of one molecule of nitrogen. So what is the total surface area? That is the total A you have to find. So if we see for this, the volume is like this. So for this STP, if we consider the STP thing, we all know this. Yeah, for STP, that is 22,400 ml will be the volume, or ml, or we can say centimeter cube, right? So 22,400 centimeter cube volume for 1 mole gas. 1 mole gas or solution or whatever the element. Okay, so for 1 mole, this is basically the volume. So you have been given here the 22.4 centimeter cube gram inverse. So what will be the for this? What will be the actually the mole number? So if we go for this 22.4 centimeter cube gram inverse, then it will give the mole number is what? That is 0.001 mole. Just unitary method, you can easily solve this problem. Okay, so the number of mole you can get there. Now you also need this from 1 mole, what the number of actually the molecules or atoms in the particular STP condition. So you all know the Avogadro number is there, 6.023 10 to the power 23. Okay, this is the number of atoms in the 1 mole in STP, right? So 0.001 mole, what is the actually the number of, just follow the unitary method and you can easily count the number of atoms there or molecules. Okay, so here we can say this answer will be 6 into 10 to the power 20. Yeah, this is the answer, 6 into 10 to the power 20 actually the number of atoms. Now just multiply these things. You have been already given the 1 molecule area and also the number of molecules you have got this. Just multiply those. And here for the calculation purpose, I will like to say that it is the angstrom, right? So you need to convert it into the meter. So that is 10 to the power minus 10. And also don't forget to take the square term. Square means it's a area means square term. So you have to square this. Okay. So then you can get the area in the meter square. It will be around 97.2 meter square and in the centimeter, right? You have been asked, yeah, in the centimeter maybe. Yeah, in centimeter square. So just convert it in the meter to centimeter and you will easily get the answer. It is 9.8 into 10 to the power 5. Okay, so option B will be the correct option. It was a pretty simple question and from your absorption actually basically, if you know this basic idea, the basic concepts, you can easily answer this question. Okay, so you got my point, you got my or explanation. If yes, you can type in the comment box also. Okay. Okay, so let's move to our next question. Yeah. So our next question is another question from our physical chemistry basically. Okay. So the question was asked from you, actually it is from your solid state, physical chemistry, not I will say that is a solid state chemistry actually. So the question was the Miller indices of the planes parallel to the B axis and intersecting the A and C axis as shown in the figure. Okay, so they are basically actually given such like a planes like this in the figure and they are given such figure actually. So you have been told there that the axes are like B axis are the parallel axis to the plane and other informations are given and you have to say the coordinates of this plane actually in the Miller indices. You have to say in the respect of Miller indices. So what will be the correct option? Anyone would like to answer this? It was another pretty simple question. Actually, just follow some, you have to understand some basic concepts and apply some basic trick approach for this question actually. So easily you can find. You don't need to mark up anything or any formulas for this. Okay, so let's jump to our solution. The correct option will be, the option 1. This will be the correct option. So why this? Why this is the correct option? So let's see, just see to the figure, our planes given in the figure actually. So let's start with the first plane. In the first plane, if we see, this is the first plane, right? This is the first plane, yeah. So how to find the coordinates? So you also know this, it is the A axis and this is the C axis and B axis is the parallel to the plane. So we all know this, the axis which is parallel to the plane is the coordinate will be infinity for that. So it will be infinity. So for A, what will be the coordinate? This point, this. You will see this 1 and 2, coordinates 2. And for if we move further from the C, axis C, so it is 1 and 2. So basically the point it comes to infinity 2. In the Weiss indices, first we should count the coordinate in respect of Weiss indices. Okay, so basically it is 2 infinity 2. Now how to find the Miller indices? Just take the inverse of this, right? So we all know this Miller indices, how to convert it. Just inverse the Weiss indices and you will get the Miller indices. So it will become half, 0, half. but it cannot be fraction. You need to figure it out in respect of the whole number. Okay, so multiply it with 2. All this. Multiply with 2. And you will get 101. So see the option, only option 1, there is 101. No other option is there is 101 for the first plane. So you can easily cancel all those answers. It is a simple thing. You don't need to follow or count for the second plane also, but you can recheck this. Whether you are right or not, you can recheck this. So let's check this, whether we are right or not. So let's move to our next plane, that is the second plane. So if you find the coordinate for this in the Weiss indices, in the respect of Weiss indices, so what will be that? So for this plane, right? Yeah, so 1, 2, 3, 4. This is 4. And another, if we see here, that is, yeah, 1, 2. Okay. So 1, 2. So 4 and 2. So we can see the coordinates will be 4, infinity, and 2. And now this inverse this, we will get 1 by 4, 0, and half. And now multiply with 4, we will get what? It will get just 1, 0, and 2. Yeah, this is the correct option. So the option 1 is the correct option. We can easily recheck like this and easily answer this question. Okay. So it was a pretty simple question on the solid surface actually, and very conceptual, very good question actually. So if you got my point, if you understood this, just you can type there yes or not. Okay, so I think I am clear to everyone because this is a very pretty simple question. This was a very simple conceptual question. So let's move to our next question. Yeah. Our next question was on regarding another thing or regarding with our inorganic chemistry. So the correct order of the electron affinity for one electron gain of the element is what? One electron gain element actually. Again, enthalpy actually they asked. So actually basically they asked in order to electron affinity, but the electron gain enthalpy for in this case actually. So the basic difference of electron gain enthalpy and electron affinity is just difference of the magnitude, no, the sign actually. So electron affinity mainly comes in the negative magnitude and the gain enthalpy just becomes in positive term. The sign will be positive. Well, there's nothing, there's the same thing. This concept already is for same, almost both. So basically for electron gain enthalpy, we should know this, that it is mainly for the third period element. It is higher for the third period element than the second period element actually. So basically for the third period element is basically it is greater value than the second period element. Okay, so we should know this. So if we see the answers, the options actually, so what will be the correct option? So if we see the option one by one, so let's start with the option 1. Here we can see that the fluorine, that is the first element, so first period element, right? So first period, fluorine is greater than chlorine and greater than bromine is given. So absolutely it is wrong, because we know this, that the third period element has the higher value than the second period element. So it's eventually, it will easily, we can cancel this. Let's move to the second option actually. Here again see this, also the phosphorus is greater than nitrogen, arsenic is there, is also wrong. We can cancel this. And if you see the fourth option, it is very, very obviously it's wrong. You all know this. You don't need to just go through the concept or anything like that. It is very, very wrong. So for this, the metal elements actually. So it is the absolutely wrong option. So it's very, very wrong. So we can easily cancel these things. This cannot be happen so easily. So option C is remaining, and it is pretty simple. That is third period element is higher than the second period element. This is the first thing here, and is the higher value. So the sulfur is greater than the selenium than the oxygen. So it will be the correct order. So option 3 will be the correct option. Yeah, this one, right? Yeah. So am I clear to everyone? This was actually the explanation which I have written here for you all. That is selenium greater than sulfur greater than selenium greater than oxygen order for electron gain enthalpy. Generally, it is higher for third period element and than the second period element. This is the basic thing actually you need to know. This is the value will be higher for third period element than the second period element. Many students actually they think in respect of their electron affinity, and that will be actually difficult for the, if we understood, if you think in respect of electron affinity, the basic thing, then it will be difficult for you to answer, because the magnitude is in the negative. Actually, the answer will be in negative form, and it will be very difficult for you to choose the correct option. So if you just thing in respect of electron gain enthalpy, that is the sign will be positive, then it will be easy for you to think these things, and you will easily answer this question. So this is a basic confusion among the students which will create for this question. So this time actually CSIR selected some easy question from inorganic, and some actually I will say some confusing terms used there just to confuse you, nothing else, just this. So I think I'm clear to everyone. Let's move to our next question. Okay, so our next question is, consider an octahedral complex Ma2B2CD where A, B, C, and D are monodentate ligands, and the number of enantiomeric pairs for the complex. So basically, it is from your, actually from stereochemistry, from your, actually you have to answer the structures, actually how many enantiomeric pairs they will form, or the optical isomers they will give. So what will the correct option? It will be easy equation actually. So if you want to answer, please type in the chat box. Is there anyone who would like to answer this question? Okay, so let's move to solution hour. How to solve this? This is a very easy equation. So if we find the structures, so we can see that all over 8 structures they will give. Ma2B2CD actually they will give all over 8 structures. Okay, so I just don't I don't want to draw all the structures. So if you draw all the structures, you will see among those only two actually will not have any plane of symmetry. All others, the 6 structures will have plane of symmetry. So basically the 2 structures will be this is basically 2 enantiomeric pairs, or the optical isomers basically we get here. Okay, so these 2 have no plane of symmetry, but all others, the total 8 structures we can draw. So all other 6 structures if we draw, that we can see that all have anyone's plane of symmetry there, but not these 2. So these 2 will show the enantiomeric pairs, or the enantiomerism, or the optical isomerism. Okay, so this was a pretty simple question. You can easily answer this question. So the answer was option 2. This was the correct option. So am I clear to everyone? Okay, so if yes, so let's move to our last question actually. So this is our last question for the today's session, and this is another question regarding your symmetry elements, regarding your symmetry, actually your stereochemistry actually. This was another thing, it's a conceptual and very good question it was. So, and easy also. The question was the combination of 2 reflections, that is sigma V prime and sigma V double prime. These 2 planes, actually the combination of these 2 planes about an intersecting mirror plane is equivalent to what? So you need to answer the operation which will eventually give the intersection of these 2 planes. It's a pretty simple question, conceptual question, just like that. So would you like to answer this question? Okay, Mika, Relay answered. Vinay, FYI. Sorry, I couldn't get you. Sorry, I couldn't get your answer actually. So which is the correct answer, you can say? Mika? Mika, can you please type what you want to type here? Can you please again type so that it will be easy for me to answer? So, this is actually your question. So if you find how to solve this question, so let's move to a solution, how to solve this question. So the correct option will be basically option 2. This one. But why? If we draw this 2 sigma plane, right? So 2 mirror plane. So if we draw, okay, let's take the white ink. Okay, now it is visible, I think. Okay, so if we take the 2 mirror plane, they are intersecting with each other, like in the question is given that they are intersecting with each other. So if we draw any point in such one mirror, so it will easily reflect to another, and it will give its reflection to here, right, in this point. And again, it will reflect with in another mirror, it will again give a reflection. And where it will be? Reflection will be, sorry, yeah. The reflection will be here. Okay, so reflection will be here. So now, just how to reach from one position to second position, this last position, how to reach. So if we perform, if we draw this, join this actually, these points actually, we will get an rotation here. Like the angle is a rotation. And what rotation is the CN? That is an rotation. If we rotate, if we just intersecting plane is here, and if between those things, if we rotate this, just we will get the reflection from one point to the next. This is just happening here. From this point to this point, how we will get? Just rotate this. Just rotate this. So it's in nothing but a CN operation, right? There's nothing but CN operation. So the correct option will be the CN. This option 2 will be the correct option. It was a pretty simple question, right? I think it is clear to you, Mika. If I am not wrong, it is clear to you. So now its answer will be the operation CN, that is option B will be the correct option. This was a pretty simple question, okay? So hope you have all enjoyed this session, this question discussion. We will again bring some few more questions from this CSIR NET in another live session also. Please stay with us, and you can easily have the concepts or for how to solve this question regarding this. And also join our class, which is also started, which has already started from today actually, and for you the next your NET examination, okay, CSIR NET examination. So this was all for today's session. So hope you all enjoyed this, and so everyone, thank you everyone, and all the best for you all.